This is 3.7, all about evaluating determinants. Follow along with me on page 15 of your notes packets if you're in my honors Algebra 2 class. All right, we will be able to evaluate determinants. So this concept, the determinant of a square matrix, it only exists when we have a square matrix. So you're like, what is that? A square matrix is a matrix that has the same number of rows as columns, and you might hear this referred to as an n by n matrix going forward in your math careers. We're only going to worry about determinants for 2 by 2 matrices. So if there's a number here, I don't know, 1, 2, 3, 4, this would be a 2 by 2 matrix because there are 2 rows and 2 columns. A 3 by 3 matrix would have, 3 rows and 3 columns. This would be a 3 by 3. That's all we're going to worry about. But in theory, these matrices could keep getting bigger, 4 by 4, 5 by 5, 6 by 6, all the way up to n by n. Every square matrix has a determinant. And so what this means in 2 dimensions, is if you picture, let's see how I can explain this to you. So say that all of these matrices represent something called vectors, and just so you know, this explanation I'm about to go into is not something that you're going to be assessed on, but just in case you're curious or if you like to know what you're doing visually, each of these rows represents what we call a vector. All right, so picture on your coordinate plane, if this 1, 2, if there was a coordinate point up here, let me make it a little bit more to scale, over 1, over 1 up 2, say that there was a point right there, and then say that 3, 4, there was another point, okay, over 3, 1, 2, 3, up 4, and then there's like these, pretend like that's straight, right, and there's these two rays. Actually, I need to make that straight or it's going to bother me, right? There are these 2 rays that we see form, okay? And then picture if we kind of like just closed our rays, right? Picture if we kind of sketched like a little parallelogram. What the determinant's going to tell us is the area of that parallelogram, right? So overall, if we have a vector, if we have a ray like this and a ray like this in the plane, we could kind of close that in, create a parallelogram, and then find the area spanned by that parallelogram, and that's what our determinant tells us geometrically. All right, that's in 2 dimensions with our 2 by 2 matrices. With 3 by 3, we add a 3rd dimension as if it were kind of like a 3-dimensional parallelogram, like prism type of thing. All right, it's called a parallel pipette, but I'm getting ahead of myself. All we need to be able to do here is calculate them. Okay, so a determinant of a 2 by 2 matrix is this. All right, so the notation is det, det, the determinant of a matrix with elements A, B, C, D. What we're going to do is multiply down this way and then subtract, multiply up this way, and then that will be our determinant. So it's going to be a number. It is not a matrix or anything. It's just a number, and you'll notice if it doesn't say like this det with the brackets, another common notation for it is just these big bars. So they'll take the same matrix, but they'll put the elements in kind of matrix form, but it's not a matrix anymore. It's a clue to say, hey, evaluate this determinant. All right. So we're going to take 4 times 3 minus, and then we're going to take negative 3 times 4 minus negative 3 is 4, 12 plus 12. All right, and that will give us 24. That's all. So I'm just looking for a number here, okay? Pause the video, give these a try. All right, so this first one, you're going to take 5 times 1 minus negative 2 times negative 1. When you evaluate that, you have to be very careful with your negatives. 5 at minus 2 will give you 3. So 3 is your determinant. Pause the video, try this one. All right, and multiply negative 5 times 4 minus 3 times 4. for a determinant of negative 32. Right? Negative 20 minus 12 will give you negative 32. That's a 2 by 2 matrix. This is for a 3 by 3. It gets somewhat involved, but the concept is the same, all right? So what we're going to do, we have this 3-step process. Step 1, 2, 3. We're going to write the first 2 columns again on the right side of the symbol, the grouping symbol, all right? And then we're going to multiply diagonally down and up. And then we're going to add on the inside and then subtract the 2 values. All right, so the best way to work through this is with an example. This is example 4 in your notes. So first thing we're going to do, step 1, what is it? We're going to write the first 2 columns again on the right side. So I'm going to take these 2 columns and write them again. Negative 3, 1, 5, 1, 6, negative 2. There are actually a couple of different ways you can find determinants of 3 by 3 matrices, but this is my favorite way. If you don't like this and you have a preference for a different one, then we can have that conversation, okay? And then now we're going to multiply diagonally down using this, this, and this, all right? Those 3. So we only use those 3 because they're the ones that have 1, 2, 3 numbers. 1, 2, 3 numbers. 1, 2, 3 numbers. This is very algebraic in nature. All right, so I'm going to write brackets so that I protect my addition. I'm going to take negative 3 times 6 times 5. Plus, we add on the inside 1 times negative 1 times 5. So I'm taking these first 2 diagonals. And then 0 times 1 times negative 2. That's just going to give me 0. Okay. And then I'm going to subtract. And then I'm going to open a new set of brackets. And I'm going to go diagonally up from the bottom left to the top right. This is why we have to copy those extra 2 columns out here. All right. 5 times 6 times 0. That 0 is going to make this entire product be 0. And we're going to add on the inside negative 2 times negative 1 times negative 3. Adding again, 5 times 1 will give us 5. And then from here we will evaluate. All right, we're going to end up with a number. Remember, determinants are numbers. So here, let's see, this will give us negative 90 plus or minus 5. Plus 0 is just, that goes away. And then minus, I'm going to keep this in parentheses, 0. This is going to give us a negative 6 plus 5. All right, and then once we're very careful with this, we see negative 95 minus negative 1, meaning that our determinant is negative 94. And that's it. Pause the video, give this one a try. It's on page 16 of your note packet. All right, I'll walk through this one with you, and then the next one, I will just give you the solution. All right, so first thing we're going to do is copy those first 2 columns again, 0, 1, negative 4, 5, negative 4, and 6. Then we're going to multiply diagonally down first. Here, here, and here, remembering that we're adding inside and subtracting in the middle. All right, so 0, this is going to 0 everything out. Adding on the inside, plus 5 times 5 times 4, 5 times 5 times 4, plus negative 1 times 6, negative 1 times 1 times 6. All right, close my bracket, and then I'm going to subtract, and then multiply diagonally up. Okay, so open up another bracket, negative 4 times negative 4 times negative 1, and then this 0 times 5 times 6, it's just going to end up being 0. 5 times 1 times 3 would be like 5 times 3. And then let's simplify. All right, so this will give us, let's see, 0 plus 100. Right, does that sound right? Yeah, 0 plus 100 minus 6 minus negative 4 times negative 4 times negative 1. We've got to be really careful with these negatives here. It'll give us negative 16, right? Because those 2 negatives make a positive, but then times negative 1 again is a negative 16 plus 0 plus 15. So then we end up with, I don't know why I just did that, 94 minus negative 1, meaning I think we end up with 95. If my calculations are right. All right, if I'm wrong somewhere in my addition or subtraction, please forgive me. I am human. Last example, pause the video, give this a try. All right, and as long as I did not make a calculation mistake anywhere, you should have gotten a determinant of -29. All right, so that's it. Take a look at your practice. Let me know what questions you have.